In the previous tutorial, we had plotted the graph of y is equal to 3 to the power x. It's an exponential function and its graph looks a bit like this. When x is negative, the y values are tiny. And when x takes positive values, the y values start increasing exponentially. So if this is how an exponential function looks, how will the logarithmic function look then? The function we have is y is equal to log x to the base 3. This is a logarithmic function. Now one way to plot the graph is by finding out the different values of y for different values of the input x. Should we go ahead then? Note that finding log to the base 3 of a number is a bit tedious, even with a calculator. Can you think of an innovative way to plot the graph of this function? As we are more comfortable with the exponential form, how about we try writing this function as an exponential one? In the exponential form, we can write it as 3 to the power y is equal to x. Now it's easier to plot the coordinates of this function. We can just assume values for y and get corresponding values of x. And remember, as they are the same functions essentially, the graphs of both the functions will also be the same. So even if we plot the graph of this function, it'll be the same as plotting the graph of the original one. Okay, so let's find a few coordinates on the right hand side. We can find the values of x for these 5 random values of y. When y is negative 2, x will be equal to 3 to the power negative 2. That will equal 1 over 3 squared or 1 over 9. When y is negative 1, x will be 3 to the power negative 1 or 1 over 3. Why don't you try finding the 3 values here? 3 to the power 0 is 1, 3 to the power 1 is 3, and 3 squared will equal 9. So now we have 5 coordinates that can be plotted. Notice that no matter what the values of y are, x will always be positive. Yes, x gets smaller when y gets more negative. But x will still always be positive. So we draw the graph like this with only positive values of x. The first point can be plotted somewhere here. X is very close to 0 and y is negative 2. The second one can be plotted here, 1 over 3 and negative 1. This will be 1, 0, 3, 1 and 9, 2. Now we can plot the graph of this logarithmic function. This is how it'll look. Now let's compare exponential and logarithmic graphs. To understand it better, we can plot them side by side. This is the graph of the exponential function y is equal to 3 to the power x. And this is the graph of the logarithmic function y is equal to log x to the base 3. What can you infer by looking at these two plots? Do you think they are mirror images of each other? Yes, they are symmetrical about this line. It's the x equals y line. And that's why they are inverse functions. They have an inverse relationship. Exponential and logarithmic functions with the same base are inverse of each other.